In order to create stored program units like procedures, functions, and packages in your own schema, you need to have create procedure privilege assigned to you. In order to create these named program units in another schema, you need to have create any procedure system privilege assigned to you. To alter a procedure created in another schema, you will need to have alter any procedure system privilege. And to execute a procedure created in another schema, you will need the execute privileges. These privileges can be assigned by a DBA. So here, in this code snippet, we are demonstrating the syntax for granting these privileges. The grant create procedure to demo grants necessary privileges to demo to create a procedure. Grant create any procedure to demo grants necessary privileges to demo to create a procedure in any schema. Grant alter any procedure to demo grants necessary privileges to demo to alter any procedure in any schema. And finally, grant execute on schema name dot procedure name to demo grants demo the privileges to execute a procedure owned by another schema. Note the procedure name is fully qualified by the schema name followed by a dot. If the schema name is not used, it defaults to the current schema. The most basic syntax to define a procedure is create or replace procedure followed by the schema name dot procedure name. Note that or replace is optional. If not used, then if there is an existing procedure by the same name, Oracle will come back with an error that the name is already used by an existing object. So I almost always use the or replace syntax, which will overwrite an existing procedure if it exists, or otherwise it will simply just create a new one. Next is the is or as keyword. After this, you can do any variable or cursor or exception declaration. Note, there is no declare keyword to explicitly start the declaration section. But after the as or is keyword and before the begin keyword is where you will declare. The begin keyword starts the execution section. Inside the execution section, you can have the DML statements like inserts, updates, and deletes, as well as the DDL statements like create or drop, along with other procedural constructs and statements to define your business logic. You can have an optional exception section. I highly encourage you to have an exception section with every program unit to trap exceptions and do the necessary actions, as well as display more meaningful messages to the client applications. Finally, the end keyword ends the procedure. You can optionally have the procedure name after the end, which I think is a good practice to help with readability. Let us take a look at an example of creating a simple procedure. Here is a simple procedure called update department, which updates the department ID of a given employee. It starts with create or replace procedure update dpt as, followed by the declaration section. Here we have declared lempid of type employee.empid %type and assigned it a value of 10. The begin keyword begins the execution section where we issue an update statement updating the empdpt ID to a value of 2 for the empid lempid. We commit the changes. Then we have the exception section where we have the when others exception handler where using dbms output.put line we show the SQL error message as well as the exception stack trace. To learn more about exception handling and exception stack traces, please refer to the exception handling section in the part 1 course of this series. We roll back the update. Finally, we raise the error again to the client. Note this is important, especially from the when others handler, so that the client application is aware that an exception has occurred. Without the raise keyword, no error will bubble up to the consuming client as it is handled in when others handler. Finally, the end update dpt keyword ends the procedure.